This chapter talks about the program processing of a SIMATIC controller. Organization blocks, short OBs, form the interface between the firmware and the user program you have created. These OBs control the behavior of the system and the reactions to specific events. Those could be startup characteristics after powering on, cyclic program processing, a reaction to an alarm, or the error handling. You have multiple OBs of the same type available to allow for optimized structuring of your machine. The firmware will initiate a one-time call-up of the startup program after powering on, or for a transition from stop to run. You can create presets for your cyclic program in the startup program. For example, you can set a specific start value for your tags and outputs. In the operating state run, the OB main takes over the cyclic program processing of the actual main program running the system. Once the controller has run all main OBs in sequence according to their numbering, it will then start again with the first one. A new cycle begins. Some processes require an immediate response to specific events. The controller offers alarm OBs for that purpose. The controller differentiates between internal and external events. Internal events are time intervals which trigger time-controlled alarms. That could be the switching on of an oven at a specific time. External events, such as signals from the machine, are handled by process alarm OBs. An example of that could be a set temperature being exceeded. Once the alarm program has completed, the controller continues working off the interrupted cyclic main program. The controller firmware calls up the corresponding error OBs when specific faults occur. The system differentiates between synchronous and asynchronous faults. A synchronous fault is always triggered at the same location in the user program, such as programming errors. An asynchronous fault, on the other hand, is one that is entirely independent of the program processing, for example, a cable break. The fault program you saved to the relevant OB now controls the response to the event. One option would be that it deactivates the affected part of the system. Priorities specify which OB is used and when. Here the following rule applies. OBs of a higher priority can interrupt OBs of a lesser priority. Cyclic OBs always have the lowest priority class. In other words, the main program can always be interrupted by external or internal alarm or fault events. Should the firmware detect two simultaneous events, then the event with a higher priority will be addressed first. How does that look in the TIA portal? The TIA portal offers assistance in the creation of new organization blocks. Various OB types for events are available under Add New Block. Cyclic OBs, Startup OBs, Alarm OBs, Fault OBs and Custom OBs for the operation of drives. The program editor in the specified programming language opens automatically when you are creating a Startup OB. You can now define the system behavior for startup or restart, let's say before cyclic operation commences. You want to count parts, but the signal cannot be reliably captured in cyclic operation. Then you simply create a process alarm OB. This OB will monitor a specific signal connected to a module regardless of the cycle of the main OB. As a first step, you specify the condition or the event that should trigger the alarm. Now you can assign this event to an existing process alarm OB or create a new one. The action to follow the event is specified in the program. In our example, the parts counter is increased by 1. The overview screen shows the properties of all blocks at a glance. The organization blocks are displayed with their respective priority. Depending on the OB type, you can change priorities as well. So, if you want to prevent specific OBs from being interrupted by other events, all you have to do is set their priority to high to reflect this. Program processing in the TIA portal allows controlled starts of your system, quick responses to faults, and customized handling of events.